Well, hey everybody, Mr. Reeves back with you, and this is our second video on lesson 7.1, writing and solving one-step inequalities. So in the previous video, I introduced you, or maybe reviewed with you, what an inequality was and how we solve one-step inequalities. And in this video, I'm going to just go ahead and work through some practice problems like I often do. All right, here we go. So I am on page 208 in lesson 7.1. So let's just go ahead and dive in and do some of these problems. All right, so we've got 4 inequalities here. These are numeric inequalities, not algebraic. They want us to add 7 to both sides on this first one, right? So I have negative 5 plus 7. All right, and then here I have negative 2 plus 7, and when I'm done, what do I get? I get 2 is less than or equal to 5. By the way, this was true. Negative 5 is less than or equal to negative 2, and after adding 7, it is still true. All right, what about this one? Negative 6 is less than negative 3. All right, that is a true statement. Now they want me to divide both sides by negative 3. All right, negative 3 divided by negative 3. All right, so well, negative 6 divided by negative 3, when I do that, I get 2. And I'm going to put the less than symbol here. Negative 3 divided by negative 3 is 1. Well, guess what? That is a false statement, right? Okay, and if you watched my previous video, you know why. Because when you multiply or divide by a negative, it takes a true statement and makes it false. So therefore, if I want it to be true, I would switch the inequality sign and say 2 is greater than 1, and now that would be true. All right, so this one, subtracting 7 from both sides, I would get 0 is a greater than negative 11. This is true, and this is also true. This one, when I multiply both sides by negative 2, I would get 2 is greater than or equal to 16, which of course is false, right? So if I wanted it to be true, I could switch that inequality sign around and say 2 is less than or equal to 16, and then it would be true. Okay, so you can add or subtract anything you want to. You can multiply or divide by a positive number, and it will not change the truthfulness. But if you multiply or divide by a negative, it makes it, if it was true, it makes it false. And so to make it true again, you have to reverse the inequality sign. All right, solving and graphing inequalities. Remember, solving an inequality is just like solving an equation. You want to use the inverse operation. So on this one, I would add 5 to both sides. On this one, I would subtract 3 from both sides. On this one, I would divide both sides by negative 7. And on this one, I would multiply both sides by 5. All right, adding 5 to both sides, that's going to give me n is greater than or equal to 3. So I would go to 3, and since it's greater than or equal to, I would color it in, and then I would make an arrow going to the right, like so. All right, on this one right here, I would get x is less than 4. All right, and that would give me an open circle on 4, and since x is less than 4, I would go to the left because this is where all the values are less than 4. Now notice on this one, I added 5. I don't have to do anything special because if it was true, it stays true. This one I subtracted 3, was true, stays true. This time I'm dividing by a negative. Was true becomes false. So if I simply put y is less than or equal to negative 2, that's a false statement. If I want it to be true, I have to flip that inequality sign or reverse that inequality sign. Y is greater than or equal to negative 2. So I go to negative 2. I put a closed circle because it's got the equal to. And then I make my line that goes to the right, like so. Okay. This one right here, I'm multiplying by 5. Not a problem. If it was true, it stays true because I'm multiplying by a positive. Even though this number here is negative, I am multiplying by a positive. B is greater than negative 5. How about an open circle on negative 5? The values that are greater than negative 5 are going to go to the right. Okay. All right, so that is solving some one-step inequalities. Remember, you use the inverse operation, and if you multiply or divide by a negative, you must reverse the inequality sign if you want it to stay true. All right, let's do some word problems now. For a scientific experiment, a physicist must make sure that temperature metal at 0 degrees Celsius gets no colder than negative 80 degrees Celsius. All right, the physicist changes the metal's temperature at a steady rate of negative 4 degrees Celsius per hour. For how long can the physicist change the temperature? So let T represent the temperature in Celsius. Write an inequality. Use the fact that the rate of change in temperature times the number of hours equals the final temperature. All right, so right here we want it to be no colder than. Now let me ask you, where would it be colder than negative 80? Would negative 79, negative 78, would those be warmer or colder? Those would be warmer, right? So no colder than means I need to be greater than or equal to negative 80 degrees. Does that make sense? Greater than is fine, less than is not. So it says use the fact that the rate of change in temperature times, so we're going to multiply, right? We're going to multiply times the number of hours equals the final temperature. So the rate of change is negative 4 degrees Celsius. So negative 4 Celsius times needs to be greater than or equal to, negative 80. Okay? Greater than or equal to negative 80. So there's our inequality. No colder than, we knew that one we had to translate into greater than or equal to. All right, now to solve that, what am I going to do? I'm going to divide both sides by negative 4. But when you divide by a negative, all right, you need to reverse the inequality sign if you want it to stay true. So C is not going to be greater than or equal to. C is going to be less than or equal to. Sorry, I use C. Let T represent the temperature in degrees. My apologies. T is less than or equal to 20. All right, and 20, what was this? 24 degrees per hour. 20 hours. Okay, so T is less than or equal to 20 hours. Or in words, we might say 20 hours or less. Right? So less than or equal to 20 hours or 20 hours or less. All right, the physicist has to repeat the experiment if the metal gets cooler than negative 80. How many hours would he have to cool the metal for this to happen? All right, so if it goes less than 80, he has to repeat the experiment. All right, so if less than or equal to 20 is okay, greater than 20 or more than 20 hours is not okay. So anything more than 20 hours. Up to 20 hours, we're okay, right? Up to 20 hours, we're okay. But anything more than 20, right? Because 20 times 4 equals 80, right? But anything greater than 20 times 4 is going to be greater than 80. And we can't have that happening. All right, I know we're going in a negative direction here, right? Okay, there's that problem. Let's go to a new one. All right, so I'm not going to solve these inequalities because I did that as well in the other video and earlier in this one. All right, just a reminder that if you multiply or divide by a negative, that's when you have to reverse the inequality sign, right? So in this case right here, I would end up reversing it. In this case right here, I would end up reversing it. Also a reminder, when the variable is on the right side, be careful with that shading. All right, so real quick on this one, I would add 3 to both sides and I would get 8 is greater than Z, okay? So 8 is right there. It's an open circle. Now, many times students see greater than and they go to the right. But what does this say? It says 8 is greater than z. That means all of the z's are less than 8, right? So another way we could say that answer is z is less than 8. So be careful of those. When the variable is on the right side, you end up going the opposite way with your shading. All right? All right, so what about number 17? The vet says that Lena's puppy will grow to be at most 28 inches tall. So we need to remember what at most means. And again, in the previous video, we talked about this. If something is at most that's as big as it can be. So if it's at most 28, that means it's going to be less than or equal to 28. Because if it went more than that, that would be more than it, right? Lena's puppy is currently 1 foot tall. All right, so 1 plus how many more inches? Let's call it I. 1 plus I has to be less than or equal to 28, right? How many more inches will the puppy grow? Well, if we subtract that 1 that it already has from both sides, what do we get? I is less than or equal to 27. Okay? So less than or equal to. So it could be 27 inches or less. Okay, so again, less than or equal to in symbols. In words, we often say that or less. All right. How about, let's skip over to this one right here. Geometry. The sides of a hexagon shown are equal in length. The perimeter of the hexagon is at most 42 inches. All right, so I'm going to call each of these S. It says they are all the same. All right, and perimeter implies we're going to add all those together. All right, so perimeter is the distance around the outside. So it's a hexagon. So there are 6 of them. So 6S. And here we go again with those words. Is at most. All right, is at most. Is at most. Okay, again, that's going to be less than or equal to. Less than or equal to. So 6S is less than or equal to 42. The most it could be is 42, but it can be less than that. When I divide both sides by 6, notice I'm dividing by a positive. So if it started as true, it's still true. S is less than or equal to 7. So if each of these were 7, it would be 42. If they're less than 7, then we would be less than 42. So find the possible side lengths. Now, even though it says less than 7, right, it can't be negative, right? So 0 is less than S is less than or equal to 7. Or we could say 7 inches or less. But remember, you can't have negatives. Okay, so if we were writing it as an inequality, that's how we would write it. It has to be between 0 and 7. Actually, it couldn't be 0 because if it were exactly 0, it wouldn't exist, right? So how about greater than 0 but less than or equal to 7. All righty. To get a free meal at his favorite restaurant, Tom needs to spend $50 or more at the restaurant. He has already spent $30, $25. How much more does he need to spend to get his free meal? All right, $50 or more. All right, so what does that mean? If I spend less than $50, I'm not good, am I? Right? If I spend 50, am I good? Sure, or more. So what is that going to be? Greater than or equal to 50. So 30, 25 is what he has already spent. Plus, I'm going to say S for spend must be greater than or equal to 50. So we want to know what that value is. Well, what are we going to do? We're going to subtract away what he has already spent. Right? The inverse of adding is subtracting. And when we take that away, we get S is less than or equal to, well, let's see, 50 minus 30, that would be 20. Take away another 25 cents, 19.75. So what does he have to spend? He has to spend 19.75 or more. If he spends 19.75, that'll be exactly That'll be exactly 50, but if he spends more than that, that will be more than 50. All right, a couple more problems, then we're going to be done with this video. To cover a rectangular region of her yard, Penny needs at least 170 square feet of sod. The length of the region is 15.5 feet. Whoops, I did not mean to do that. The length of the the length of the region is 15.5 feet. What are the possible widths of the region? Okay, this is the arrow I meant to press because I wanted white space over here. So, the area of a rectangle is length times width. Okay, the area of a rectangle is length times width. All right, and we need it to be at least. So at least means greater than or equal to. So we want an area of greater than or equal to 170.5. And it says the length is 15.5, and here is my width. So 15.5 times W must be greater than or equal to 170.5. All right, so I'm going to divide both sides by 15.5. All right, so here we go. 15.5 into 170.5. By the way, it's okay if you use a calculator, but this is a good reminder of how to do it without a calculator. I'm going to move that once there and that once there. All right, so 155 goes into 170 one time. By the way, the decimal's there now. And I go 155. Here we go. All right, so that's a 0. All right, I'm going to borrow from here, make that a 6, and that's a 10. 10 minus 5 is 5. 6 minus 5 is 1. Look at that. Huh. It goes in exactly one more time. Okay, so what do I get? I get 11.0, so it goes in 11. So the width right here would be 11. Okay, so it needs to be at least, so this is greater than or equal to 11. So 11 feet or greater. 11 feet or greater. So remember, the area of a rectangle is length times width. All right, one more, and then we're going to call it a day on this video. All right, Selena has $10. What is the greatest amount of spinach she can buy? All right, well, we've got yellow squash, spinach, onions, and potatoes. Spinach is $3, right? So $3 times the number of pounds of spinach. She has $10, so it has to be less than or equal to 10, right? $3 times the number of pounds, so I would divide both sides by 3, and I get S is less than or equal to 10 thirds. All right, now I know you guys know I'm not a big fan of mixed numbers, all right, but when we're dealing with sometimes things in real life, we want to, especially if we're talking pounds, 10 divided by 3 is going to be 3 1/3 pounds, all right? Or if I was to put that in words, 3 1/3 pounds or less. Well, actually, it says what is the most she can buy. So the most she can buy is 3 1/3 pounds. All right, Gary has enough money to buy at most 5.5 pounds of potatoes. How much does he have? All right, at most is less than or equal to. So if I do 5.5 pounds times, let's see, what do we buy in potatoes is a 50 cents, right? So I need to do 5.5 times 50 cents. Well, 50 cents is half, right? Half of 5 is 250. Half of 50 cents, or half of 0.5 would be 0.25, right? So what are we going to get? We're going to get 2.75. So he has $2.75. $2.75. So when you multiply those, that's what you would get. All right, finally, Florence wants to spend no more than means less than or equal to $3 on onions. Will she be able to buy 2.5 pounds of onions? Well, let's see. 2.5 pounds of onions times $1.25. All righty, so 2.5 times 1.25, is that going to be less than or equal to 3? There's our question here. All right. So we need to know what is 2.5 times 1.25. Again, if you want to use a calculator, that is absolutely fine. All right, I'm going to do it the old-fashioned way here. 5 times 5 is 5. Carry the 2. 5 times 2 is 10. Plus 2 is 12. Carry the 1. I get 6. I'm going to put a 0 here. 2 times 5 is 10. Carry, I'm going to erase these because I need it again. 2 times 5 is 10. Carry the 1. 2 times 2 is 4 plus 1 is 5. And 2 times 1 is 2. So when I add those together, I get 5, 2, 6 plus 5 is 11. Carry the 1. All right, and I had how many decimal places? 3 decimal places. So this right here is 3.125. This right here is 3. That is false. So the answer is no. It's really, really, really close. All right, but 3.125 is just a little bit too big. All right, so actually in terms of money, that would be what? $3.13 if we round it up, right? So $3.13 is greater than $3. So the answer is no. All right. Okay, so hopefully that is enough to get you through this lesson on writing and solving one-step inequalities. Until next time, have a great day.